Hello and welcome to the Digga podcast, where we talk about everything to do with earth-moving attachments. Join Digga CEO Alan Wade, product specialist Anthony Weekman, and head of marketing Lionel Smitka for a blend of helpful information, interviews and funny stories from the past 40 years.
Today we're delving into the world of Augers, or Auger bits for our American listeners. As we say hello to Alan and Anthony, I'd like to start with a 5-star review. This review comes from a BW in New South Wales. Alan, you're such a naughty boy. You didn't tell me you were doing a podcast.
Thanks, Barb. Seriously? Did she write that?
No, she didn't. That's just a stitch up, Al.
Oh, good.
But for anyone listening, we were at a trade show 2019 Las Vegas. And Barb, for anyone listening, is Alan's mother. She left a message on Facebook, on the Digga Facebook. She must have seen Alan on a promotional video, and she left a comment to say, "Alan, you're such a naughty boy. You didn't tell me you were going away." And that's to 50,000 of our followers.
Didn't I cop it off the guy over there?
We still use it.
Yeah,
But
yeah.
Barb, we know that you're tuning in. You're right, he is a naughty boy.
Thanks, Barb.
All right, on with the show. Alan, you'd have to agree. The number of augers that we manufacture year in, year out is astounding. Where do they go?
No, it is. It's crazy. I mean, back to my early days and, when I first started, you distribute a few augers here and there and you don't think much about it. But now, I think we were just saying before, it's literally we're doing 2,000 auger bits a month. And that's crazy. That's every month in, month out. It's just,
And that's Australia only.
that's Australia. Yeah, it's not adding in what's
What the UK are making, what the US is making.
No, the UK. The UK is manufacturing their own. The US, they manufacture a lot of auger bits. What do you say, Ant, when you first started at Universal?
Yeah, I thought 10. I got an order for 10. I thought, well, we're not going to make... this isn't going to be a career for me because everyone will have an auger bit in a few years' time. And here we are, and people are, ordering 200, 150 augers at a time per order. So,
But when you think about it, everything takes a whole. Foundations, street sign, fence post.
Yeah. I remember telling when we were sort of touting Bobcat for their work over in the US, and one of the main players inside Bobcat, he had to get it across to his board, about putting auger drives and auger bits onto large excavators because they just didn't believe it was an attachment for a large excavator. And he sort of made the comment, guys, when you leave here today and you drive home or wherever, just have a look. Everything you see needs a foundation. Every light post, street sign, bollard, everything. It needs a foundation. Yeah. And of those foundations, 99% are drilled.
Yeah. All right, so let's start by exploring the main components which make up an auger. We'll start with the most important part of the auger, the cutting head. Anthony, can you tell us what makes a good cutting head?
so obviously, you can set a group of teeth in any position that you want, but if you haven't got those teeth at the right angle and the right attack angle, and then to handle the washout and coverage across that head, then you just set yourself up to fail straight from the beginning. So we've taken a lot of time and effort and research over the years to make sure that we have our teeth and pockets all positioned so that you're getting the optimum attack angle and you're getting good coverage across those pockets so you're not getting wear on those pockets.
So when you talk about attack angle, there's not just the angle so that the tooth is hitting the ground of the right angle. There's also the travel path. Obviously, the outside tooth travels further or faster than the inner teeth.
Yeah, that's why you your outside teeth will always wear quicker than your inside teeth. So they're obviously, as you said,
They're doing more miles.
Yeah, travelling further. They're bigger. They're doing the full diameter of that hole, whereas your inside teeth ain't doing a small amount. So, and it's in a tighter angle. So you've got to make sure that they're turned in and getting the front part of that tooth is hitting the ground, and it's ripping that ground up. It's breaking that ground. So. There's two styles in an auger. There's an auger that cuts and grinds, and then there's an auger that rips and breaks and chips the ground out. So, depending on whether you're getting an earth auger through to a dedicated rock auger, then that's how we've got to set those teeth so that that it attacks that ground the best it can.
So a customer rings up and goes, I've got an auger that drills really well and an auger that doesn't drill as well. Is that generally based on the configuration of the teeth?
Yeah, it could be configuration of teeth. It could be the style of auger that they're trying to drill in that ground condition. So one auger won't do all ground condition. There is no one perfect auger that's going to do your soft clay through to hard rock. They're just different setups and different, it's like a builder turning up and to build a house with a chisel and a hammer and expecting that he can do all the jobs to build that one house. So, you need to have, if you want to drill in all ground conditions, if you want to be that guy that can turn up to a job and no matter whether you're in clay or rock, that you've got the tools to do the job, then you might have to have a general purpose auger, a rock combo auger, and then a dedicated rock auger. And then we're into the specialty rock drilling stuff like tapered rocks and core barrels and all that sort of thing. So they're drilling tools. So you need many tools for the trade.
All right, we'll cover some of those augers in more depth shortly. But let's move on to flights. Obviously, the flights help the spoil come to the surface or to help bring up the surface. We talk about pitch, which is the angle that the flight is on. Can you talk to us about the pitch and why you would have a steeper or an...
Yeah, so again, you in our general purpose range that we're putting the mass out, we try to find that happy medium between a steep pitch and a shallow pitch. So a steep pitch is going to get your soil out of the hole quickly, but if that's very light material, sandy and it's dry, then it's going to slip off. It's like a steep slippery dip. Whereas if it's shallow, it's going to sit on there better. If your ground is wet and sticky and clay, then you run the risk of it binding up and getting stuck. So we've, how many times do we sit around debating what's the better angle, and you end up,
We find that for your shorter augers, just your standard augers, 1,200, 4 feet, overall length, that you want the flatter pitch because you're only taking that minimal bite each time out. But then when you get to a continuous flight auger that could be, say, on a saw mech or something like that, that could be 6 to 9 metres long, they don't want to have all that spoil on the auger in the hole. They want to get it to the surface quicker.
Get it out.
It's less weight, less. The more weight you've got on the auger, the more power you need to drive that auger. Even though you're still cutting, but you also got to turn that weight.
That bit of spoil that's 6 metres at the end of the cutting head is pushing that soil at the top. So that's power that you need to push that.
So they want it out quicker. I remember years ago with a guy Dave Goodman, a good customer of ours, and he builds his own drilling rigs, monster rigs, and we were building his augers for him, and we thought we were doing the right thing by just flattening the pitch a bit to hold the spoil on, because he was doing sand and a lot of sandy jobs, and he rang us up and he said, don't flatten the pitch. Can you put it back to a steeper pitch? He said, I want to get that soil or the spoil out of the hole quicker. He said it's less weight on the auger, and so that's how you learn. You learn from your customers, because they've obviously got a specific.
That's probably been one of the successes of Digga, is that we do listen to our customer base and we do take their feedback and put it into practical with improvements on the product. So.
All right, so the last part of the auger, the shaft and the hub, obviously the hub drives from the auger drive. And there's not much to talk about the shaft other than, we do see some shafts that come back bent.
It just bent.
It just bent.
Just bent.
But I've seen you do a trick with a straw, Al, just to explain that.
Well, I had and this is something that goes back a long way, and I've shared this with all the sales guys, was that, a customer came to me one day and with a bent auger, an A4 auger on a Bobcat or a skid steer, I should say. He said it just bent, and they don't just bend. I said there's a reason for it to bend, and I had a plastic drinking straw in my desk drawer, and I pulled the plastic drinking straw out and stood it up on the table in between me and the customer, and I put my finger on top, and I pushed down on the straw, and I said, I'm pushing down, with a fair bit of weight on top of this straw, it's not bending. And I said, you put your finger on top of mine and push. And he put his finger on top of mine and he pushed, and we couldn't move that straw until I touched the straw on the side and it folded. Yeah. That's side load. And that's what is I'd like to say 100%, but, there's always that once, but it's literally 100% the reason that augers bend is because side load.
And the reason that they bend the auger, obviously, the machine when you go down the hole bends in an arc or lowers in an arc.
We've found that you'll have a more incidence of bending augers when the augers are being driven off a skid steer, and a skid steer with tyres as opposed to tracks, because when these guys are pushing down, they're trying to put as much weight as they can on that drive unit, pushing that auger into the ground, and they tend to lift their wheels off the ground, and they'll have their wheels, half a metre off the ground. And what that's doing, it means that the rotational drive of the auger is causing the skid steer to rock backwards and forwards, and they're constantly fighting that movement, and it then just throws it sideways. When the auger's in the hole, it'll throw it sideways, and it gives it that side load and can bend.
Okay.
Yeah.
Now, let's move on to teeth. There's different types of teeth. We do 3 different types. Anthony, do you want to take us through the types of teeth and when to use each type?
Yeah, so you got your flat-bladed style tooth, which is used on our A4 series, and a slightly larger version on our A6, and they're like a butter knife or a serrated edge steak knife. It's going to peel it out, and that's going to be your best bet for doing just your general post hole borers on a skid steer and your excavators up to sort of 4 ton. It's going to have the ability to just have that real cheap tooth, an earth tooth. It's a hardened steel, and for that guy, he's pulling out of his auger out, a couple of times a year and drilling a couple of holes on the farm. Through to the guys who are using it with MFT teeth, which is our tungsten carbide version. Now, if you run that flat tooth all the way across, you will be able to use that in shaly sort of ground, and it'll break that ground up and grind away. Then you move into our rock combo, or earth rock combo auger. Now that's it just reduces the width of that tooth. So if we look at the flat tooth, it's got 3 pieces of carbide as a width. And then we move into that round tooth, which has got the 2 pieces of carbide, and it's on a taper fit pocket, so there's no need for the rubber lock or anything that like that is used on the A4, and it just locks in. Now, being smaller, like a lady's heel, it will pierce the ground a bit better, so you're going to start getting that you get more ability to get into the harder grounds, so it's going to start doing that bit of harder shale, bit of your decomposed sandstone, that sort of thing, and still but have the ability to get the ground out of that earth if you're getting into some soft ground, it's not like trying to drag a point through the dirt. So
another thing with that RC auger, that rock combo, is that if you were to turn the auger on its end and be looking directly at the
pilot,
and just for instance, a 450 or 18-inch auger actually probably has 22 inches of cutting teeth. It's like you look at it's an S-shaped. So the S-shape, in the S-shape, it's cutting 450, 18-inch. But if you were able to grab those two outside teeth and straighten that S-shape out, it's actually cutting probably 4 inches. Not cutting 4 inches wider. It's got 4 inches more of cut inside that 18 inches. And that's just one of the unique features of the RC, that how they've worked so well for years on end.
Yeah, you get that good coverage. You got the ability to drop in a single pointed tooth if you need to fracture the ground. Some ground will fracture and break into chips, some you have to grind. So it's got the ability to adapt to the ground conditions that you're in. If it needs to be purely a grinding auger, then your RC is the way to go, because you've got that 100% coverage all the way across, and it'll just grind away that hard rock that doesn't want to fracture out. So then we move into our sort of more the specialty style cutting heads, like the dedicated rock, which is uses a rotating pick tooth. So we're going now down to a single pointed carbide. So again, like a lady's heel, that will pierce the ground, compared to an elephant's foot that is wide, and that pressure from the machine is spread across a larger surface area contacting the ground. It's then divided up into a series of points that's going to burst the material out. So, and then that can be put into a couple of different configurations with tapered rock and spiral rock augers and those sorts of customised type heads.
Right, we'll discuss rock drilling a little bit further down the track. Just going back, the average customer will probably be in the flat tooth to the tapered tooth. Now, we run a single point or a chisel tooth in the middle, and we run a bit of a wider tooth on the outside. Can you explain why we do this?
Yeah, so that's again trying to get the best setup to do the majority of ground. So that chisel tooth in the inside, that acts as the word would describe it, a chisel, and it breaks up and fractures that centre out. So it's designed to try and get the hole done a bit quicker. It's going to break out in chunks rather than having to cut the whole lot out. And again, because you haven't got as much surface area contacting the ground at one time, it lessens the power required to drive that auger. So if you notice that you're getting a washout behind the point of the chisel tooth, or you're getting some rub marks on the pocket, then that's telling you that the ground that you're in is not fracturing, it's not breaking out and chipping. So those chisel teeth are then creating a groove in the rock or the ground material that they're doing. So you need to be proactive, you need to knock those teeth out, those chisel teeth, and then fit the wider tooth across it, so that you're getting, again, that full coverage across it and grind your material out rather than break your material out.
And some guys, their job requirement will ask for flat tooth right across. Guys doing foundations for slabs. They've got a certain depth they've got to go to. I know in the Sydney region it's called auger resistance, and it's normally at 1800. That's the depth they've got to get to. But when they get to that depth, they need a flat hole, and those guys have found flat teeth right across.
Yep.
Gets them to that depth and gets that flat hole. A couple of spins and a bucket of water and a couple of spins, and their job's done. And they can normally those guys can normally or they'd like to do a hole in basically two passes. One pass down to get to the 1800, come out, clear the auger. Second pass in is basically just to clean up the residue and move on.
So you could run flat teeth all the way across if you're drilling in clay as well.
Yeah, yeah.
They will have a better result than running chisels.
Yeah. Yeah. Well, the flat teeth are better for clay, because they'll shave it like, as Ant said, like a knife over butter. It's
it'll peel the clay away, and get you into depth a lot quicker than sort of having to push the chisel through, which is then like trying to drag a knife through the butter.
Yeah.
So we should make the point that you can run flat teeth all the way across the auger, but you can't run a chisel all the way across because that end
Definitely
tooth...
not.
No, you don't get your clearance on the outside.
It's like putting a worn tooth. A worn outside tooth will lose its outside corner first. That's the first wear that you will get on that tooth, and to the point where that entire outside corner will be gone, and it'll be in the arc of the diameter. So if you put that chisel tooth on, you're basically missing that entire outside corner, which is the clearance over your flights. So you're going to be starting to wear on the corner of your pocket and your flights, and you'll just wear away the diameter of the auger.
So I guess a bit of a tip would be, and we covered it before, the outside's travelling further, the outside tooth's wearing faster. So it's to swap the outside tooth for an inner tooth.
If you don't have a replacement tooth, the trick is, move your outside tooth to your inside, move your inside outside. So that's on the taper ones.
The tapers,
taper rocks.
Or if you're running the flat tooth or the MFT tooth all the way across, so your flat teeth all the way across in every single pocket, your outside one is going to start losing that outside carbide, whereas your inside, it'll have some signs of wear, but very minimal because it's not working very hard. So you would knock that one out and then move that to the outside, and then move your outside one to the inside, so that you're getting the best value for all your teeth. So,
all right. So going back on drilling in clay, our suggestion would be to run flat teeth across the whole surface of the cutting head. Any other tips for maybe removing spoil off the auger? I know that mud and clay can be a bit tricky.
Yeah. Dipping the auger in water.
Definitely not forward and back, which is a common mistake a lot of guys make. With that, how many times have we seen that, Al? Or a guy comes in and goes, it just made a click noise and now I won't turn. And that usually means that the dog bone in the motor has snapped. And the best way to imagine it is like hopping in your car and throwing it in a drive, and then while you're still doing that 10, 20 kilometres an hour, throw it in reverse and go backwards. That's essentially what you're doing to your gearbox. So all that inertia of the weight of the soil, the auger, everything, and you're throwing it in a reverse. While it might get the dirt off the auger quickly, it's going to damage your gearbox. So.
Forward. That's probably the golden rule.
Forward, stop.
Yep. And it'll slide off. And like I said before, there's little tricks. If you've got water available, like in a drum or something, a 205 litre, 44 gallon drum of water, is to dip the auger in the water. And this is mainly only when we're talking about wet clay, or damp clay, especially after long periods of rain. That's when you'll get a sticky auger.
So what if you can't shake the clay off?
So I guess the next thing is you have a sacrificial hole next year. So somewhere where you're not going to be drilling, or just next to you drill the auger down again to the depth that you need to top of the flights to get to, and instead of then stopping and lifting the auger out with the spoil on, you then reverse the auger out of the hole. That will then, it's either pushed off what was already on there, and then it leaves the dirt that's down there, and then you just keep using that same hole in and out each time to get the spoil off.
All right, let's talk about rock drilling. How hard a rock can you drill before you got to bring in a drill rig?
Well, it comes down to the host machine. So we can do rock augers for your mini loaders, through to, your 50-ton excavators and beyond, your Sawmac rigs. So each auger is built for that machine, but ultimately it comes down to the down pressure that the host machine can generate through those points on the rock auger to burst the material out. So, we all know that you can get a piece of rock, a crumbly sandstone, you can crush in your hands and it turns to crumbly rock. And then there's that rock that is just, it's like a quartzy, compacted rock that no amount of hitting it with a hammer is nearly not going to break it. So it really is dependent on the host machine. I quite often use an analogy of if you're drilling a hole in a wall with a hand drill and you've got the drill above your hand with your arm fully extended and you're drilling into that wall, how much harder that is to actually penetrate the wall compared to if you're down at shoulder width and you've got your whole body and pushing it in, it will get into it so much easier. So it's exactly the same when you're applying that to rock drilling. It comes down to the down pressure that the host machine can generate to burst the material out.
And then equal to that, you've got to have the torque in the drive head to support the weight of that machine.
Yeah, so you're pushing down, not it just stalls because you're doing it. So
yeah, you have too low a torque drive unit on a heavy machine and it pushes down, especially on hard rock, the drive unit will stall.
Yes.
So is there a rule for size of machine that you need? So can you drill with a 2-tonner?
Yeah, by adding a dedicated rock auger or a tapered rock auger to your tool supply, your tools that you're using to get into that ground, you're going to do harder ground than what you would normally do with a general purpose auger, but it doesn't mean you're going to do all rock. It doesn't mean you're going to rock in there with a 2.5 tonner and be drilling out 250 MPa rock. You just haven't got the down pressure to get into that, to penetrate that rock. You could try it with an RC auger and just purely sit there for hours grinding away and probably spend as much time replacing the teeth as you are drilling. But there's just horses for courses. Sometimes you're just not going to get into that rock with the machine that you've got. You need down pressure. The biggest secret of getting into rock is the combination of the rock auger that you're using, but it is down pressure from that host machine.
And we'll have and we've had it in the past. There is rock that's virtually undrillable. There's classes of rock they say is blast. It's blast only. You just cannot break it out with an auger drive. Sydney Electricity, they used to do when they were drilling, and they had to put power poles have to go in regardless of whether it's sand, soil, clay, shale, or rock. Those power poles have got to go into that depth, and they would resort to. If they're going to put in they say they need to drill a 450 hole in solid rock, and they can't penetrate it with the 450 auger, they'll go in with a 300 first and just take out that 300 of rock. Then they'll go back in after it and then put so they'll start the hole at the top where the rock's weathered. They'll start it with the 450, so they've got that guide. Then they'll pull that auger out, put a 300 into the centre, and using the pilot hole, they get the centre, and then they can drill that 300 down. Then once they've got that 300 in, they'll pull that out, put the 450 back in the hole, and then they're only taking out.
Yeah, reaming it out.
Reaming it out. So they're taking less amount out.
So if you don't have the down pressure to break the rock, you're sitting on top just polishing the rock, which in essence could makes it harder.
Yeah. Glazes it.
Yeah. Glazes up. You're just superheating all your tools. That radiant heat that is generated down through the cutting head travels up right through the post or the tube of the auger and into your shaft, and then if you're down there long enough, it's going to radiate up into your gearbox as well. So you're not doing yourself any favours by constantly just holding it down there and trying to grind away. You need to still be relieving it out of the hole, let the air get down there, bit of water to keep everything cool, and try and get into that way. You can slightly, not while you're drilling, but you lean it over to one side and you take it up, a scallop out, so you're putting more weight down on one side, and then you can rock it out. So you're instead of going down flat, you're going down left, right to try and gouge that rock out. And then you've got the guys that invest in extra tools like a tapered rock. So dedicated rocks will create steps in the rock, which is across those steps will try and break that corner of that rock out. Then if that's getting stalled, you introduce a tapered rock auger, creates bigger steps, hopefully it breaks that rock out, and then you'll use a combination which goes in line with what Al was saying the electricity guy's doing, where they're putting smaller diameters. So your tapered rock is a small diameter through the pilot out to your full diameter. It will drill down, you get stall, you put your flatter auger back in, you drill that out, knock the steps out, and then vice versa, backwards and forwards to achieve your depth.
And there's one bit we haven't spoken about on your auger is your pilot. The pilot is one of the most important parts because it's the first piece to touch the ground. It's the first cutting tool that's penetrating.
Yes, if that's not going in,
if that's not going in, you could have the best teeth in the world, surrounding it. If your pilot isn't cutting, or it's and I've seen it many a time where people say, "Oh, just put all new teeth across the auger and it still won't drill," and you go and you drive halfway across the country to get to these people, and you get there and they pull the auger out of the ground and the pilot is smooth as a baby's bum.
Looks like an ice cream cone.
Yeah. You change that out, they put it back in, they oh wow, is that all it was?
Yeah. We've actually pulled a pilot out of a hole that was glowing red.
Yeah.
I think temperatures were around the 300-400 degrees Celsius. So
very quickly too.
So,
the guys that leave their augers just down the hole for 10 minutes, without relief, will destroy.
Yeah.
So is that why rock augers generally have less flights? Is that so that you don't load them up with spoil, so that you take them out of the hole more often?
It is to encourage that, yeah. If you've got a 2 metre long auger and you got 1.8 metres of flighting, guys will tend to want to drill down until that flight is completely filled up. Now, if you're in rock, that could be 2 hours before you reach that depth, depending on how hard it is. So, if you have a shallower flight, then it's full, so the guy tends to bring it out. So that's sort of one of the reasons we do shorter flighting.
Mm.
So how often should you come out of the hole? Obviously, it'll depend on the rock, but is there a general rule that we use?
I always say, if you're in solid rock, 5 minutes max, and that's regardless of whether in 5 minutes you've gone down 100 mil or you've gone down 500 mil. Just bring it out, because the more regularly you actually bring it out, I always say the quicker you drill the hole. People say that's ridiculous, but if you put that auger in, you leave it in, like I say, 5 minutes tops, you bring it out, you're doing a couple of things there. It's letting you look at your outside teeth to see that you've still got outside teeth and you've got clearance on them, but it's letting air back into the hole, and it's what you call relieving, because so if you can imagine drilling down in a rock and that spore that you're drilling travels up onto your flights, and then it basically creates an oven beneath it, because it's sealing off the outside air. So you're dispersing all that air through heat. And if you leave it there, you'll glaze the hole. You'll be making the face of the hole harder, or the face of the hole that you're cutting, you'll make it harder than what it was when you started drilling. And
so every 5 minutes you bring the auger up, you're inspecting the teeth, you're making sure the teeth are still free spinning, free turning?
If it's in a rotating pick auger like a DR auger, but even in your RC augers, just where it's a fixed tooth and they don't rotate, it's just allowing you to look at those teeth.
Yeah, make sure you haven't lost the carbide.
Yeah, just check those outside clearance. And your outside two or three teeth on, say, an RC auger, are probably the most important. Your DRs they've got your outside two because you've got the cut, and then you've got a gauge tooth. As long as they're all in good condition, then you don't even have to get out of your machine or whatever. You just pull it out. You look at those teeth as you're spinning it to clear the spoil off, and then go back down the hole and repeat it, and guarantee it's been proven. You'll drill that hole quicker. You'll use less wear parts, which means it's more money in your pocket. Not so much ours, but it's more money in your pocket.
That's a good point, because when you're leaving the spoil in the hole, that spoil is acting like sandpaper around the wear parts.
Yeah. Especially in that dedicated rock. So the pilot, in that dedicated rock auger with the pilot, it has replaceable teeth. So it doesn't mean that host or that sub-pilot doesn't wear out. It just means that you have the ability to replace the teeth in that pilot, and you have the ability to repair that pilot by way of, hard facing, or some guys weld a little bit of cutting edge on it and all that sort of thing to try and lengthen the life of that pilot. But ultimately it's still a wear part, and it still will wear out. But if you're in hard rock and you're getting a soil build up around that pilot, even though that it's powder or crumbled rock and it just sits there, if you're at a bit of an almost stall where you're not getting down and you're just holding that auger in position and down the hole and letting all that spoil just sit around that pilot, it will just wear it out, and you'll come up and the side of that pocket will be worn out and destroyed in, it could be destroyed in one hole, it could be destroyed in half a hole if you don't bring it out regularly to get that spoil. Put a little bit of water in there to bind up that powder so that you can get that powder material up the flight and out of the hole away from the cutting head.
All right, so we touched on torque earlier, but if we could talk about a relationship between torque and speed. Obviously, you don't want to auger in rock at too fast a speed. You'd only be sort of skipping over the surface. So is there an ideal speed or torque required?
Well, I guess lots of torque is always a benefit.
More torque.
You can never have too much torque.
Never have too much.
Speed, definitely, if you're in rock drilling, you don't want to be spinning at 40, 50, 60 RPM. You want to be probably around that 23 to 30 RPM is a nice grind for rock. If you're skating over the rock too quickly, then you're not getting that ability to penetrate.
Really, the teeth are looking for a fracture, and if you're going too fast, you're going to jump over that fracture. But good heavy down pressure, plenty of torque, and just a slow speed, and it'll find those fractures. It'll break those that rock out. Shale, really hard shale that just rips it out. But it's all about finding those fractures in the rock and pulling it out.
So if the dedicated rock auger doesn't do the trick, we can move to the tapered rock auger, which Anthony, you mentioned earlier. A tapered rock is, as it suggests, it's tapered. It's like an upside down Christmas tree. That allows them to take less bite. But what if the tapered rock doesn't work? What's the next option?
Well, you'd look at a core barrel would probably be your next option. The core barrel, so instead of having to remove your entire diameter, so if you're trying to do a 600 diameter hole, and instead of having to remove that entire 600 of rock, you're cutting a ring around that rock. So that ring is probably about 75 mil. So you're only removing 75 mil of material, so really takes less power and down pressure than to get into it, and that's the theory behind that core barrel. The drawbacks of core barrel is that you need to fracture that core off. So if you've reached the depth of that core barrel, which is most core barrels about 1.5 metres, so you might have an effective depth inside there of say 1.2. if you haven't reached past that rock, then you've got to break that off. Now, that there's a few different techniques, none of which us as a gearbox manufacturer like either, because you're side loading to try and break that off. Most guys, if the rock's too hard, will drive in wedges to try and break the core, or it'll just naturally break. Hopefully it'll break once you reach the depth, and you'll come out as a core in that core barrel, and you drop that out.
All right, so any tips? I've heard you, Anthony, talking about putting some chokes under the wheels of the machine.
Yeah, so as Al was saying earlier about guys when they're drilling on skid steers, and they'll be up on their the front wheels will be up off the ground, and they're rocking on their back wheels, and they're trying to get as much down pressure as they can. So ultimately, if we think about a skid steer loader is designed to lift from the front, so it has the weight at the back of the loader, so it naturally just wants to sit back on its bum when you're pushing down with those arms. So if you got money to invest in a nice set of rear stabilisers, hydraulic stabilisers, then that's the way to go. But not everyone wants that on the back of their loader. So a good cheat is to get basically a railway sleeper and or a big chunk of wood, and you sit that in behind, chock it behind your wheels basically, so that when that loader goes to rock back and its bum drop onto the ground, then it hits on to that piece of wood and changes the pivot point. So it's not rocking on the wheels, it's then allowing the hydraulic cylinders of the load arms to actually put the full force of its down pressure through those arms and get them the maximum amount of down pressure that you're going to get.
I think that work, and that's all good on the skid steer loaders and even mini loaders. When you're drilling on those, is just to again put that a block of timber under your step, your back step, and that'll just transfer that weight. As opposed to going backwards, it'll transfer that weight to go forward. With an excavator, and most excavators have got blades. Put the blade behind you, drop the blade down, and that'll transfer the weight. So instead of the excavator wanting to lift the front off the ground and roll back, the blade will tend to keep the weight going forward, so that it'll keep the weight on the boom and subsequently on the auger bit.
So Anthony, you've probably spoken to thousands of people regarding drilling, or rock drilling in particular. What's the biggest mistake or suggestion you would have for people?
Probably the biggest mistake guys make is not maintaining their wear parts, not getting rid of that tooth after it's done its serviceable life. So many guys you'll see that as Al mentioned, the pilot stuffed, or the teeth are completely worn out and it's wearing into their pockets, and they continue to try and drill. So it's just going to cost you big bucks to try and repair that, or ultimately throw the auger away and get a new one. So if you look after those wear parts, then the auger will last you many, many years. Replace the teeth, replace the pilots. Then even when you're moving into, if you're getting into those dedicated rock augers or the tapered rock, it's like having a high performance vehicle. You've got to service them a little bit more. They're a little bit more pedantic in how you've got to maintain them. They're not just a drill and then throw in the back of the truck for a month until you pull it out again to drill. So if you're in that rock, the auger's getting hot, you've introduced water, so you've got mud in there, so all that dirt and spoil is in around the teeth, and it can bind those teeth up. Those teeth are designed to rotate. The rotation doesn't give you the penetration. What the rotation gives you is the even wear around the tooth. So the tooth should be looking like it's been in a pencil sharpener. It should be nice, round, even wear. If you're getting like grooves in your rotating pick teeth, that's telling you that tooth has stopped rotating in the hole and you're just getting a washout. Now, it will continue to drill, but what it will do is wear out behind the carbide. The carbide drops off, and then within minutes, you could be destroying a pocket and having to be repairing that auger. So, if you're in that situation, your end of the day, you should really be knocking out those rotating pick teeth, knock them out of their pockets, pressure wash it down, get all the dirt out, and don't put grease in it. A lot of guys, I even spoke to a guy the other day, he said he greases his teeth up. While that's great and they'll spin while there's no dirt around them, as soon as you introduce that into the dirt just mixes with the grease, creates a paste, and then it'll just bind them up even more. So keep them dry is the best while they're out of the hole, so that you're not getting rust. If you just put it away and those teeth have got spoil and they're wet, they're just going to rust in there, and no amount of belting those things will get them out. You'll end up having to cut the pocket out to repair it. So, a bit of maintenance at the end of the day will save you lots of dollars in trying to fix it later on.
All right. Well, we might leave it there for our Augers session. Thought we'd finish off with some stories. Do you have any stories for our listeners?
Are these auger-related stories, or
they
just
can be
general stories?
General stories, whatever you like.
You'll tell us about Williams down in...
A good customer in Sydney, company was LJ Williams, owned by Dave Collins. He's he departed, and I was actually running around visiting clients in Sydney with Stuart, founder of Digga, and we got a call from Dave saying that his 450 auger was only cutting a 350 hole, and okay, well that's not possible, but let's go and have a look. So we drove by the job he was on, which was a cutout of a sandstone, basically
like a quarry or something, was it?
Oh no, it was a house. It was in Janelli in Sydney. It was a house site that they'd cut the side of the hill away, which was just all sandstone. So he jackhammered or rockhammered all that away. And then he was drilling the foundations. I think they were putting in a garage below, and then they were building above. And anyway, when he saw us turn up, he jumped out of his cab and came over. He was still drilling, still had the auger in the hole, and he came over and got his tape out and threw it across the hole. It was 350. And I just said, well, you sure you've grabbed the right auger? And he said, it's a 450 job, So I said, where'd you first start? And he was in it was like either hole 12 or 15 or something, and it was solid rock from top to bottom. I think he had to go down 1.2. And we went over to where he started in the morning, measured the hole, it was 450. And he looked at us and looked at the hole and looked back at the hole that measured 350 and thought, what the... And so what he'd done, it was classic what we were saying about relieving the hole, coming out every 5 minutes and just, letting the air back in, checking your outside teeth. He was actually just putting that auger in the ground and just sitting back. I think he put his foot up on the stick pedal and sat back and said, oh, well, I've just been, because he said it's a boring job, excuse the pun, but it's a boring job. And he said, I make phone calls, booking the next day's work, whatever. And when it finished drilling, he just lift it out of the hole, clear it, go to the next hole. So he progressively, from that first hole to the 12th hole, he'd worn off, a whole tooth on both sides, a whole pocket, that part of the head, and the flights all the way up. He had a perfect 350 auger, and I said to Dave, I said, look, we can throw it in the ute and I'll take it back to the workshop and the boys they'll build it back up and back out to a 450. He said, no, it cuts a perfect 350. I'll just get me another 450. So we ended up supplying with a new auger, and he went back and he basically just reamed those holes out the next day with a new auger.
Hence why we sell 2,000 augers a month.
It's probably why we sell 2,000 augers a month. Yeah. No, that's a
classic story that we hear all the time.
Yeah, it's an example. But in Dave's, to give Dave credit, he basically slapped himself in the face and said, how dumb am I, and then move on.
Anthony,
Oh, no, probably not as funny as that one. There's, you hear the stories of guys that they've, again, it was in Sydney, and he had a setup on his, he had a PD5 for his 5.5 tonner, and it was about a metre diameter auger, so he was already pushing it, but he couldn't get his 5 tonner in there that day, or he couldn't get his 5 tonner to site, so he just welded a couple of ears to the bottom of his 20-ton excavator hitch that he normally runs his PD 40 or 50 on, and he was just pushing that auger down, and he's got me out there looking at it just to see how it was cutting, and I'm sort of saying, mate, this is not built for 20-ton machine. He goes, yeah, I know that. He goes, I just wait till the tube starts to flake a little bit. When the tube starts to flake, and when metal's about to yield, it actually flakes the skin off. So that was his litmus test of when he was about to fail his auger, because he's running this ruddy auger.
We need more customers like that. It'd be 3,000 augers a month.
That's it. So, but he achieved the hole and he got it done. But it certainly wasn't something that we recommended. That was for sure.
Well, all right, we might leave it there for our second episode. Until next time, thank you for tuning in. Goodbye for now.
Goodbye.
Goodbye.
Before we go, if you have a question regarding this podcast or a topic suggestion for a future podcast, let us know by emailing podcast@digga.com. We'll try to answer your questions in an upcoming episode. If you enjoyed this episode of the Digga podcast, don't forget to subscribe or follow so you don't miss the next one. And leave us a 5-star review while you're there. And also don't forget to tell your friends about it. Remember, you can follow us on Facebook, LinkedIn, Instagram, and through our website digga.com. Thanks for listening.